Imagine you're in a cave. You find diamonds, but you're skeptical of a creeper coming up from behind, so you decide to check your surroundings. After a quick sweep, you find nothing, so you start mining. And then boom, a creeper. What happened? Where did it come from? The simple answer is that it spawned. But I have a better question. Where was the creeper before it spawned? Now, although you might think that the creeper was nowhere because it just spawned, I assure you, it was somewhere. To understand where mobs are before they spawn, you first need to understand how Minecraft as a game works. Minecraft is like a two-sided coin. On one side, you have what you see, graphics, and on the other, you have what the game thinks, logic. Now, while you're playing the game, these two sides combine to become one, but they are separate. And there are very good reasons for doing this, as many games follow this pattern. Let's take a look at one of the reasons for splitting the logic from the graphics. Imagine you and your friends get that annual itch to play Minecraft. Somebody volunteers to host, and assuming you're all on the same network, that same friend hits open to LAN, and you all connect. Looking at this example from the perspective of a two-sided coin, the friend that is hosting your world is also hosting the logic of the world. When other players connect to the world, they connect to the host's logical side of Minecraft. A two-way connection is now established between the server and each player. Now let's say that the server decides to spawn a skeleton. Since the server is purely information, it doesn't need graphics. The server then tells each connected player near the skeleton that it now exists. The player's game will store the information of the skeleton, and each frame it will use that information to draw the skeleton in the right place. As a quick side note that I think is quite interesting, this is why things like rubber banding exist. The position that the server is storing is not the same as the position that the player is storing. Moving back to the logic side of things, the one takeaway that is extremely important to understand the question in this video is that the player is seeing a visual representation of what is on the server. Even if you are on single player, you are still only seeing a visual representation of what is running on the server. Now knowing that mobs are actually on the server side of the game, this sparks the question. If the mob isn't what I see, then what is it? The answer to this question is quite technical, and to understand what mobs truly are, you first need to understand how Minecraft was built. Minecraft is entirely written in a programming language called Java. The specific type of development used to create Minecraft is called object-oriented, event-driven programming. Now that might sound confusing, but it's actually quite simple. Everything in Minecraft is an object. Blocks, objects. Items, objects. People, objects. The other half of the equation is event-driven. Simply put, the way that the server handles logic in the game is through events. For example, when a player breaks a block, that's an event. When an event takes place, an event handler takes that event and adds it to a queue with other events waiting to be processed. The next time the server ticks, it handles the events in the queue in the order they were received. Now that you understand events and how they are processed, let's take a deeper look into certain objects, specifically entities. All entities are objects, but not all objects are entities. A skeleton is both an object and an entity, while a chunk is an object, but not an entity. There are two main ways to distinguish between objects and entities in this context. Firstly, an object is a Java term, which refers to any instance of a class. And an entity is a specific term within Minecraft that refers to something with changing elements. This would apply to things like mobs, players, and items. Secondly, entities are unique in that they can dynamically update within the game. They support changes in things like position, velocity, and health, and they can interact with other entities or players. Think of entities as interactive or living objects, whereas other objects like blocks are static and fixed. For example, a skeleton, which is an entity, can move, take damage, and attack, while a chunk, which is an object, represents a static section of the game, storing things like blocks and entities. Here's an example of an object. This is a simplified version of the block type, stone. First, let's make this code way more easy to understand. There are two things in here to pay attention to. This line tells the game what sound to play when it gets broken, and with what tool you can break it. This line here is also pretty simple. It just tells the game where to put it in the creative menu. Note how there is nothing here that allows the block to change dynamically. Therefore, it's not an entity, it's an object. Now at this point you might be wondering when we're actually going to be getting to the answer to the question of where mobs are before they spawn. And I assure you, we're almost there, but to truly understand the answer, you need to know how Minecraft was built, what entities are, and now how they function. Now that we understand the difference between an entity and an object, we can take a deeper look into entities and what they really are. In the Minecraft code, we have something called class inheritance, and the best way to understand this is visually, so I'll just show you. Think of inheritance like a family tree. At the top, you have your grandparents. In the middle, you have your parents, and at the bottom is their children. Let's simplify this family tree and take a closer look. With genetics, we'll assume that your grandparents here both have blue eyes. In this case, the child has a 100% chance to also have blue eyes. And if both of your parents have blue eyes, then so will you. The trait is inherited from the parent or grandparent. The Minecraft code is almost exactly like this. The tree is just much larger. So, let's make this more simple. We'll take a look at the skeleton, for example. Let's start at the top with entity. Before we get into this, I do want to highlight one major difference between the family tree here, and it's this word, abstract. Abstract defined is existing in thought or as an idea, but not having a physical or concrete existence. What this means here is that the entity class only exists as a blueprint to inherit. It does not appear physically in the game. We only want to inherit its characteristics and nothing else. Moving back into the skeleton family tree, we can see that it starts with the entity. Here, we have traits like current position, velocity, and even the entity that is riding it. You can see that specific trait here. The spider is being ridden by the skeleton. The ability to do that comes from the entity class. We'll move straight past entity living and entity creature since they both serve a similar purpose. We'll go straight into entity mob. This is where we see traits like attacking another entity. Finally, we move into the skeleton. It's important to note here that we stop seeing the word abstract, because the skeleton is actually in the game. In this entities class, we see all of the attributes that are unique to the skeleton, such as the sounds it will make when it dies or when it takes damage. So now we know what mobs are, and we know how they work. But the final part of the equation before we can fully understand where they are before they spawn is how they spawn. And that starts with the game loop. 20 times per second, the server side of the game thinks. Every time the server thinks, it's called a tick. Let's see what that could look like with this simplified game loop. So this here is how the server thinks. This is what we call the main game loop. This line here just tells the computer to repeat this block until we want to shut the server off. Simply put, this is going to run forever until we shut the server down. The first part of the game loop is taking all of the input from the players. This might be breaking blocks, moving, or even attacking. We then take all of this input and move into the next line where we update all of our data. If the player says they moved, we update the location of the player, and in the next section here, we send the updated information to relevant players. If a player broke a block, we tell them what items it dropped. Or if a player moved, we tell nearby players where they moved to. But I want to go back and focus on this line here. Part of the game logic is deciding where mobs spawn. But how is that done? Every tick of the main game loop, the game looks at all chunks near players and decides what creatures to spawn, if any. The first step in this process is to get all chunks near players that are allowed to spawn creatures. Then, for every chunk, we see if the spawning conditions are right for the creature we want to spawn. And then boom, we spawn that mob. So, let's recap our understanding. Minecraft has two sides, graphics and server. We learned that the server is where the mob and all of its data is stored. We also know that all mobs are objects in Minecraft's code. We now know about creating attributes to inherit from their ancestors. We know that the game, 20 times per second, looks at where to spawn mobs, and then it spawns them. Great. So, where are mobs before they spawn? The simple answer to this question is that they're nowhere, but they are also somewhere. You, as a player, do not see the mob before it spawns, but that doesn't mean it appears from thin air. Think of it this way. The entity in Minecraft's code is a stencil, and every time Minecraft wants a creature, it takes the stencil, copies it, and pastes it into the game. So again, mobs are both nowhere and somewhere. They exist in the form of a blueprint, like a stencil waiting to be used to paste a copy of the mob into the world.